All right. Hello, explorers. Welcome to Reach the World. My name is Tim. I'm so happy you're joining us today. We have some very, very special guests who are joining us today all the way from Cape Town, South Africa, as they prepare to embark on an expedition. They are part of Expedition 393, the South Atlantic Transect 2, and we're going to learn all about what that is and what that means and where we can expect to go on this virtual exchange expedition for drilling in the South Atlantic Ocean. I have so many questions about that, but I want to turn it over to our special guest. Let's go right to Tessa, who is the onboard outreach officer aboard the JOIDES Resolution, just about to set sail from Cape Town, South Africa. So Tessa, I'm going to unmute you. Welcome to Reach the World. How are you today?
Hi, Tim. We're doing great. Thanks for having us.
Yeah, of course. I'm so glad you can join us. Can you tell me a little bit about who you are and where you are?
Of course. So my name is Tessa Peixoto. I am the onboard outreach officer. And if you think of the acronyms, I'm an OO. And I help handle all the outreach activities, create resources for educators around the world, and also handle the social media. So you'll be seeing a lot of posts from me if you follow the JOIDES Resolution on Instagram or Twitter or Facebook. And we are in Cape Town. We're actually at the dock, so you can see the gangway right behind me that leads up to the boat. And that just helps us get on the dock and off the dock onto the boat. And soon we won't have the gangway anymore.
Can you tell me, Tessa, where are you from and how did you get to Cape Town?
Yes, so I am from São Paulo, Brazil, but I am coming from Boston, Massachusetts in the US. And the way I got here was I just am a super enthusiast of science. I really like science. Personally, started out with sharks, but it has widened out to the whole field of science. And I'm so excited to learn from all these scientists on board because even though they all like rocks, they all like different parts of rocks. So I want to know more about rocks, more about mud, more about sand, and just understand how it helps us know about our world.
All right, excellent. Well, you're giving us a little preview of what the mission of this expedition is. And I know you have a special guest with you, Dr. Steve Bakar, who is a geologist. Can we say hello to him and ask him some questions about what he's doing there? Hi, Dr. Pekar.
Good afternoon. How you doing, Tim? It is great to be in Cape Town, South Africa. And I just want to let you know about this amazing expedition that we're about to go on. We're actually part of this huge program that's been going on for over 50 years now. We have 2 big drilling ships. There's over 20 countries that belong to this big program. So we're all working together. It's kind of like Star Trek on Earth, where all these countries work together, no national posturing. And so, and this organization is called the International Ocean Discovery Program. So it's international. We got ships that go around the oceans and we're just trying to discover. And this is what an exciting program this is. And what the program has done is that I'm part of this amazing project from IODP. I'm going to call it IODP from now on. And it's called the South Atlantic Transect. And it's such a big project, it's going to take 4 months to complete. And so we are the last expedition to do this. There's been 4 expeditions that have gone out to collect sediment cores from the bottom of the ocean and also rock cores going down over 2,000 feet below the sea floor. That's like 600-700 meters. And so we're about to leave, and we are basically the grand finale of this amazing project.
That is absolutely amazing. And Dr. Picard, this is not your first time on the JOIDES Resolution, is that right?
That is correct. This is my 4th time. And every time, this is, like I said, this is the closest I'm going to get to being on the Enterprise with Captain Kirk. Because we are on, well, maybe not a 5-year mission. We're on a 2-month mission to go where boldly go with no drilling bit has gone before. And so we're going to be making discoveries. The last 3 expeditions, the sediment cores and the rock cores that we've gotten, we're already making major discoveries. We still have to write them out. It's going to take some time, so we can't give away everything. But so we're the grand finale of this. And so in each expedition I've been on has been magical. The scientists, just think about it. I have 29 other scientists working with me. And on this expedition, representing over a dozen different countries. And we're all working together. And everybody's got expertise in sediments or rocks or biology. Because this project is, typically on an expedition, we're after, like trying to figure out climate change in the past. That's what I work on. Or we're looking at volcanism. This expedition, this project here, we're not looking at just one goal, like climate change. We're not just looking at two, like microbiology. We're also, with this, a threefer. We're looking at climate change. We're looking at microbiology, looking at life that shouldn't be existing deep inside the earth, but it does. We're making major discoveries. And then the last one, which is the most important, in fact, is we're going to be drilling actually into the ocean crust, deep into the rocks, to figure out how this evolves through time. And it's all deals with plate tectonics and so on, and lots of other things I'll talk about in the coming weeks.
Excellent. I want to come back to you in just a minute to ask more science-related questions, but if I could, I'd like to ask Tessa really quickly. I can see in the background that there's a lot of activity going on the JOIDES Resolution as it prepares to embark, leave Cape Town Harbor, and head out into the South Atlantic. Can you tell us about the ship? What makes the JOIDES Resolution a special kind of ship? It doesn't look like most ships I know.
Yes. So Stephen can help me with this, but the JOIDES Resolution is such a really interesting ship. So there's the derrick right back there. That is where the pipes that we need to plummet down below the water, the surface of the water, all the way to the bottom of the ocean. So it works from that part, it's called the derrick. And what's really cool, there actually is an Instagram post, I believe, that talks about the noise that you can hear as that derrick is working to work that pipe into the ocean's crust. It is also, correct me if I'm wrong, 50 years old?
This ship?
Yeah. 40.
It's in the 40s.
40 years old. So it's been working for year after year, trying to do what Stephen was talking about, really answer these questions about the Earth's history. And it has living quarters so that all the crew can work 24/7, but get some sleep in the middle of it. It has lab stack, which is basically the floor where all the labs are. And so we have a chemistry lab. So anyone who wants to look at little parts of how things are made up of, they're paying attention to that in there. But there's also the people who want to look at the fossils. So there's a little lab for them to like sift through all this sand that comes up with the core and look for those fossils. We have a galley, which is where all our food is. And we even have a snack time that has cookies and ice cream machines. So we are taken care of for treats. And let's see. Is there anything else you would like to know about all the different amenities that the ship has?
You know, it sounds like it is a tiny floating village that supports all of your personal and scientific needs, but is it fair to say that it is designed specifically for drilling at the bottom, underneath the ocean?
Yes, it very much is designed for that, mainly because what's different is that most ships will generally have just an anchor to like drop down and stay put. But what the JOIDES Resolution has to do separately is it has these 4 additional parts on the sides of the ship that we call dynamic thrusters, right? Dynamic thrusters. What they do is as the ship is trying to drop the pipe and actually drill into the ocean's crust, the dynamic thrusters are working against any push that we experience from waves so that we become even more stable than just having an anchor down. And they look like basically really big fans underwater, under the boat. Essentially, that's what they look like when you look at a diagram. But they turn on and they're controlled by a computer, and they turn on every little movement they feel. They'll turn on, fight a little bit with the push of the ocean water, so that we stay as stable as we possibly can. We'll still move, but less. We'll move less.
That's pretty amazing. I think for most people who are getting ready to go on this adventure with you through this virtual exchange, how ships work in the ocean and how you could even get a drill bit down that far underneath the surface of the ocean is kind of amazing. And I'm very excited through your eyes to show that to more people, especially young kids, because it's kind of a mysterious world. And like Dr. Bakar said, you're going to the bottom of the ocean where we don't know a lot about what's going on. It's still kind of a mysterious land. So Dr. Bakar, I know over the course of the next few weeks, we're gonna really get into the science of what this expedition is doing and what it has been doing over the previous months. Can you tell us why a geologist like yourself would be really interested in being a part of this expedition?
Oh, there's so many. Well, first of all, what I do for a living, I study climate changes in the past. And so scientists are like detectives, like a Sherlock Holmes or a Nola Holmes, actually, would probably be. And so we're trying to collect, clues from the sediments or from the rocks to figure out what happened in Earth's past. And since we're looking back at time, we're not only detectives, but also time travelers. So I am excited about being on this ship again, because when we extend, well, first of all, we got to extend height through something like about 17,000 feet of water. That's about 10 World Trade Centers stacked on top of each other to get down, just down to the sea bottom. And then we're going to drill
Even deeper.
Even deeper, 600 to 800 meters. That's 2,000, 2,700 feet. That's like stacking up a couple of World Trade Centers, just core, whether it's sediments or rocks. And every foot, every yard, it's got a historical story to tell. It's basically, we're looking at Mother Nature's made a book for us, and we're peeling away each page, and we're reading each page of the history of this area, which is going to be way out in the middle of the South Atlantic Ocean between Argentina and South Africa. So we're going to be really in the middle of nowhere, to tell you the truth. But and so for me, I'm excited because we're going to get sediment cores that have never been taken before in this area. This is really unique. The strategy that the people who designed this project have been really thoughtful to really try to maximize, so we can get as much really important sediment cores that tell us about climate history of the South Atlantic. And if we understand the South Atlantic, we understand the world. But the even more important reason, there's two other aspects, is that we're going to be also drilling into the ocean crust, getting igneous rocks, basalts, if you know about science and geology. And then we're also going to spend a lot of time. We have, I think, four microbiologists who are going to be studying life inside the sediments, growing and living, and even inside the rocks.
So let's just pause there for a second. So microbiology is looking at life that's so small, we need a microscope to look at it.
Big microscope.
So it's smaller than even your hair. So like just one strand of hair, it's much smaller than that. So they're going to be using lots of microscopes to look for that life. And just quickly make sure we know what a core is. So a core is like a cylinder. So if you look at like a very tube-like water bottle, for example, we're taking that, essentially that shape, and just making like a cutout, like a cookie cutter from the mud and the rock. And we're just bringing up that cookie cutter like tube shape upwards to the boat. To the ship, because it's bigger than a boat. And what's really cool is what Stephen had brought up, is we're really turning pages of Mother Earth's story. But the thing is, it's very much like pages. Each layer in that sediment, in that sand that's been packed down with pressure, is very thin. And so we need a lot of technology on the boat to really look at each of those pages, those really thin layers of sediment. So just wanted to make sure we knew what we meant by cores and those layers of sediment there.
Yeah, thank you. Thank you.
Thanks a lot. Yeah.
And so let me summarize, if I could, just for a minute, because I know a lot of this science is very new to our audience. And the general idea is that over the course of millions of years, and correct me if I'm wrong, all the things that happen on Earth sort of settle to the bottom of the ocean, and they form layers and layers and layers and layers on top of each other. And by drilling down into the bottom of the ocean, way beneath the water, you are picking up little clues about what happened at each of those time period as you pull out this tube-like sample of everything that has accumulated at the bottom of the ocean, down through the sediment, the loose, relatively loose stuff, and even into the rock of the crust of the Earth.
Correct. So for most of you who are like me, who like biology, like life and living things, we are looking at the parts of the rock that were present on the surface of the Earth when maybe the dinosaurs existed. Or even, if you are like me, I like the megalodon, the big shark in the history. So even when that existed. So even though I'm not necessarily a rock person, I need my rock people to tell me about the environment my favorite animal lived in.
All right. Well, it sounds like the specialties and interests of all the people on the ship will contribute to forming a really big, full picture of what likely happened on our Earth, or what our Earth was look like many, many, many years ago.
Yeah, and in fact, let me just clarify. We're going to actually go back just not a few million years ago. We're going to go back to about over 60 million years ago. To give you an idea how far back that is, the dinosaurs got wiped out around 65, 66 million years ago. Our course will get almost deep enough to get back to the time of the dinosaurs, but not quite. That's how far we're going to get back. And we're going to have a complete story of Mother Earth's history from this area of the world, going back that entire time interval.
That is absolutely incredible. I'm so excited to follow you both and to meet some of your colleagues along the way as well, and see what you're doing out at sea. It's one of the cool things about this virtual exchange is that you have invited us, and you're going to be our hosts to follow you on this expedition as you leave Cape Town, and we're going to get to experience this science in action as you drill beneath the ocean, which, you know, prior to meeting you, Steve and Tessa, I wasn't even sure was possible. That's amazing that you can drill down that far, and I'm very, very excited to see what that looks like. Let me ask you both, what are you most excited about for the coming months as you're out at sea aboard the JOIDES Resolution and exploring in the South Atlantic?
Well, to start off with the science, it's we're going to, like I said before, we're going to boldly go where no drilling bit has gone before, and we're going to complete this saga of 4 expeditions spanning many, many months. So we're going to complete this, and we're going to fill in all the missing pieces. You know, the first expeditions for 60 million year old and 7 million years old, we're going to be right in the middle, and we're going to capture the rest of those sediments in between and all those rocks in between. And now we're going to have by the time we finish, hopefully if we have good weather or decent weather, nothing breaks, we're going to have the complete story. This will complete the project's goals. Wow.
Amazing.
Yeah.
Tessa, what are you looking forward to?
A little bit of everything. I haven't been on a ship for so long. I've only done ship tours like for a day. So being on a ship for 2 months, I'm really interested to see just how much of the ship is an ecosystem. Everyone depends on everyone to make sure that it goes successfully. So I want to be able to be a part of that team. And I hear a lot of good things about the food. So I'm excited about that part. Beyond the science, of course, I'm super into the science, but I'm also excited to see sort of life at sea.
Excellent.
Yeah,
I know. Oh, go ahead, Dr.
Yeah, I was just going to interject that, yeah, I agree with that. Life out at sea is a magical time, and I'm looking forward to sharing not only with the students in New York City, but I invite any school around the world to join us in this expedition, the grand finale of months and months of pouring and science and struggle. And we're going to complete this. So any teacher that's got students or whatever, we would love to have you to be part of this adventure.
Yes, and I'll be taking you along that adventure mostly, but you'll see Stephen and all the other scientists as well.
Fantastic. You know,
Started doing some stuff.
I love, based on what you're both saying, that this is, you know, this is the end, sort of the final expedition to piece together a story that many, many people have worked on over the course of many months and probably years. And there's a spirit of international cooperation and curiosity and discovery that in the end, when all of this data is put together, we're going to know a lot more about what our Earth was like 60 million years ago. That is a wild journey. Can you do, Tessa, if possible, can you show us a little bit more of what the ship looks like in port and the area around?
Yeah, of course. Let me just move because they're using the crane, so I need to be out of the area. So let me switch my camera. So that's the front of the boat, and on the top layers, that big orange thing is our lifeboats. And then, like I said, that's the derrick, and right now they're using the crane, so I have to move out of their way. And then if you go all the way back there, where's my hand? You'll see the end. So we're a pretty big ship.
Yeah, how many people will be on the ship during this expedition?
I think we can host
120 people.
120 people. Mm-hmm.
Okay, excellent. You said there were about 30 scientists in that group. Who makes up the rest of the expedition team?
So that'd be the catering team. We also have a cleaning staff that helps make sure that the boat stays hygienically clean and safe for us to live in. We have the engineers who operate the derrick and the cranes and the boat. We also have our ship captain and the first mates and all the ones that are able to help drive the boat and understand what it means to have like a boat at sea. I wouldn't know how to do that, so I want them to deal with that. So it's more than just scientific research vessel. We need so many other people to be able to do that.
Excellent. All right, now I know there is a possibility we were going to have one more special guest. Is he able to join us?
Yes, he is right here, but I think the noise is really loud right now, right?
I can hear you pretty well, actually.
Oh, okay. So
yeah.
let me see if he's ready. They are over there. Are you ready? Okay, they want to go inside. So give me 1 second.
Sure.
Yeah, let me switch the camera so you can see. So that's our crane that's currently working right now.
All right. What is it doing right now? Can you tell?
They're moving a lot of crates and boxes that need to go onto the boats. So they might be moving some material onto the boat that we'll need for the ship.
All right.
Or maybe they're taking it off because they already unloaded it.
Great. And when are you actually planning to leave port?
So we are hoping for June 11th.
All right.
But we do have some wiggle room. And we have that for June 12th.
Okay, so within the next 24 or 48 hours.
Correct. Yeah.
Excellent.
It's exciting.
Okay. Excellent. Well, while we're waiting for Trevor to come, I just want to let our audience know that Tessa and Steve and others aboard this expedition will be writing articles for Reach the World. Dr. Pekar has already written his first article. You can find it at reachtheworld.org. And I hope that you follow the articles, read all about what's happening. We're going to have lots of pictures and videos from this expedition, in addition to all of the live stream events that we'll be able to host from the ship as it is out in the ocean and this actual scientific research is being conducted. So the combination of all of those things is going to make us all feel like we get to join the JOIDES Resolution on this expedition and to be scientists this summer as this team is completing the final chapter on this story, trying to figure out what the bottom of the ocean can tell us. It looks like we're walking now in through the JOIDES Resolution to the inside of the ship.
Yep. So what's really cool about our stairwell is that every expedition that has happened on this ship has a logo on this wall.
Oh, look at that. That's cool.
So,
Wow.
It's
That's a
all,
lot
it's
of
all over.
expeditions.
We have a lot of expeditions.
So actually, this one here,
Yes.
and this one over here are expeditions that I was on.
Oh, you were on those.
Yeah.
That's great. Yeah, we have a lot of people who are coming back to an expedition. So there's even one person who's been on 9.
Whoa.
Yeah. Let's go over here.
It's very
So let me give you-
interesting to be able to see the inside of the ship. For those of us who have not spent a lot of time on ships, especially research ships like this, it's very, very cool.
Yes, so right now we're in the core lab. So where Stephen is right now is where the cores, once they get brought up and cut up into smaller pieces, we'll go over there. But we also have more lab space over here. So when I say we have lots of different labs, I am not kidding. So this is an example you see right there. The plastic piping, that's where those cores are coming up. They come up in like a plastic pipe. So this room is used to split them into half, or for the microbiology people who want to get their microbiology samples first before we do any destructive methods on the core.
So drilling
All right,
and retrieving the cores is really just the first step of a long process. It's collecting the scientific sample from underneath the ocean and then bringing it up aboard the ship where scientists can look at it really closely and try to pick out or discern what they're looking at, what the clues are telling them.
Oh yeah, and especially for people who are microbiologists, chemists, they're looking at things that are so small, you need other technology to help you get that information. So a lot of the stuff like chemistry, they're looking at elements that are so small, they're the most basic unit of the matter. So we'll need technology to tell us how much of those elements are in there. Are you looking at calcium, or are you looking at maybe, I just learned a new word, ophiolite, the other day, which is not an element, but it's a form of rock. So let me let Stephen talk about what this room is for.
Okay, so we are now in the core lab. So the core lab is a laboratory for cores. And what we do is we first take cores, we split them in two, so one half does not get touched, except for us. And that's always have a half of the core, and we just lay them out, because when we drill, we obtain over 30 feet of core each time. So how do we well the 30 feet of core? Well, we cut them into 1.5 meter length. That's about a little less than 5 feet. And then we split them and we lay them out here. And then I'm one of the sediment quality describers. And we describe the core. And the way we do this is that we look at it with we have little hand lenses to take a look at it. We don't have one here. We have books to tell what the color is. So we have books like this. We can match the color. We can also look at it with this big microscope. Let me bring over some of the microscopes.
Are you hearing okay, Tim?
Yeah, just make sure, please, when you're speaking, Dr. Pekar, that your face or your mouth is facing the microphone. Then we'll be able to hear you really well. This is fascinating.
Okay, sure. And so this is one of the big microscopes. And I'll just take it off so you can see what the lenses look like right in here. And right now we don't have any samples, and so I can't really show you, but you can see how this is not like an ordinary microscope. It spins, and it's got different powers. We can take camera pictures of this. And so we'll have two people who look at sediments who are going to be specializing looking at the sediments through microscopes. My preference is to look at it with the hand lens and try to describe it and give color and how big the grains are, what type of grains, whether it's a fossil or maybe it's like a piece of quartz or something like that, or if it's clay. And so we have a team of just four sedimentologists. Those are people who look at the sediment cores. We're going to have a whole nother team that's going to look at the rock cores, and they're called petrologists. That doesn't have to do with petroleum like oil. It just means rock in this case. And their job when we reach when we finally drill so deep that we reach the ocean crust, that's going to be the rock. And they're going to take over, and they take over this lab, and I'm going to be there to help them because I love to learn. And so, and I got an A when I took petrology many years ago, but I want to learn a lot more. And we have some of the best scientists in the world that deals with ocean crust on this expedition.
So the lab right now is pretty quiet, but it sounds like that's going to be a busy place as soon as you start pulling up those core samples from the South Atlantic Ocean. That's going to be the center of activity.
Yes, it's basically, it's 24 hours a day, 7 days a week, but we don't work 24 hours. We break the science group into 2 12-hour shifts. So I'm going to work from noontime, Cape Town time, noon until midnight, and then the other half of the scientists are going to work from midnight to noon. So this lab never stops. And when we reach the hard rocks, then the hard rock people take over. When the hard rock people take over, and we're going to probably have so much core to describe, we're going to be able to probably move this ship to the next site. And we're just going to have to hope that we finish everything before we start pouring again. So it's going to be nonstop, but it's the funnest job in the world because we are basically exploring, being detectives, and being time travelers all in one job.
So something I want to say, which is something I discovered when I was learning science about potentially being a marine biologist, is that science, our vacation is our field trips. And this JOIDES resolution is our field trip.
It's the ultimate field trip.
It's the ultimate field trip. And these are very valuable because they give us the data or the samples that we need to be able to talk about it in classrooms, in conferences, to share with friends, to share with people around the world. So we need field trips like this, and we don't get it very often. So we have to work hard, get as much as we can so that we have enough for future years. So the expedition doesn't stop after August. These scientists will keep working on these cores for years.
Many years, in fact. So I was on an expedition from 12 years ago, and it took a long time to understand how old the sediments were. So it took years for that, and then it took years for me to process all the data. I had 800 samples, and I had undergraduate students working on it. It took years, and finally, it's been, and I'm starting to write the paper now after 12 years.
Wow.
So, and what's even cooler is that even though it's 30 scientists, we still can't do all the science. There's no way. And so I actually have a student, a graduate student, who looked at some IODP cores, and no one had worked on it for what we wanted to work on. And he says, I'm going to do my PhD on these cores that are 40 years old, 35 years old.
So we're still finding out secrets from previous expeditions. So what I like about science is we never stop asking questions. Even when we have data, we have more questions. So curiosity takes us farther than any motivation.
That is amazing. It sounds like this expedition and the chance, even though Dr. Pekar, I know you've been out on the JOIDES Resolution before, like every time you get a chance to go out on this special ship that has a special capability of pulling up more clues from underneath the ocean, it's like a treasure trove of information that will fit somewhere within the bigger picture of what we understand about how our Earth has evolved over the years. I am so excited to follow you over the rest of this expedition. It has been such a pleasure today to talk to you both and meet you both. This is just the beginning of our virtual exchange together. I would encourage anyone who's watching today to go check out Dr. Bakar's first article at reachtheworld.org, where he has introduced himself in some more detail and talk a little bit more about the science that's going to be happening over the next few months. Good luck to you both as you embark from Cape Town in the next day or two and begin that journey across the South Atlantic. Before we go, is there any sort of final message that you'd like to give to the students who are joining this expedition?
I would just say, welcome. you know, you're going to be going on an adventure that you probably never expected. Okay, I'm going to bring you into a time machine. We're going to go back in time, and we're going to explore the ancient world together.
And the only other message I would say is, because I am the OO, the onboard outreach officer, if you want to keep coming back for more information about the JOIDES resolution, I did say we are on social media, and you're more than welcome to ask for a free ship tour yourself with your classroom or your museum or your library. It's for anyone who wants to join, any age, and I will make sure it is understandable wherever you are.
Fantastic. It's such a great opportunity for you, or thank you for welcoming us onto your ship. And as a part of this expedition, we're so excited to join you on this adventure and this quest for knowledge and curiosity. So good luck to you the rest of the day. I know it's later in the afternoon there, and you need to get on with your work. Thank you so much for joining us today, all the way from Cape Town, South Africa. And until next time, take care.
Take care.
Thank you. Have a great day.
Bye.
Bye-bye.
Bye.